The vocabulary words we're going to talk about today are, I want to make sure we understand the difference between factors and zeros. Right? And sometimes zeros are called roots. All right, so factors and then zeros and roots. I've used zeros a fair amount. I haven't used roots very much. I need to use roots because a lot of books some books call them zeros, some books call them roots. So I want to make sure you understand both. So here's a real simple example about factors, connecting factors and zeros and roots. Let's say I give you a polynomial, that's x squared minus x minus 6. I can factor this. If I factor it, it's x minus 3, x plus 2. All right? And so these are your factors. Everybody okay with that? And if you set each of these things equal to 0, where you get 3 and negative 2, I'll change colors. These are your zeros or your roots. All right. Everybody okay with the vocabulary words? I mean, we've kind of been doing this for the past couple of weeks, but now I'm kind of officially calling it, all right, when you do this, these are your factors. And when you set each of them equals 0, that gives you your zeros. And some books call them roots, so I have to talk about roots. Right? And so what are we doing today? Well, today, so it's easy to find factors and zeros if it's quadratic. How do you find factors and zeros if it's not quadratic? What if it's bigger than a quadratic, right? So what if I ask, well, what I want the factors and zeros of, let's do 2x cubed plus x squared minus 13x plus 6. So I want to find the factors and zeros of this. All right? Has everybody written that down? Okay. Now, so let's get some other terminology out of the way. There's something called the fundamental theorem of algebra. Right? Here's what it says. Whatever the degree of the polynomial, that's how many zeros you're going to have. So, how many zeros am I going to have? 3. If I've got 3 zeros, that means I can have 3 factors. Right? Everybody okay with that? And so our job is, okay, given this, how do we get our 3 factors and our 3 zeros? Right? That's it. That's the job, right? Now, we've actually done something similar. See, the something similar was like last week, I gave you this and I gave you a hint. Remember we did something where I gave you a polynomial and then I gave you a hint and then you divided and that way you could find everything out. So today is about what do you do if I don't give you a hint, right? So how do you figure out your new hints, right? And that's something called the rational root theorem, or rational zero theorem. So I'm going to write that over here. That's actually what I'm talking about today. And we're going to talk about the rational root, and some books call it the rational zero theorem. And here's what the rational root or zero theorem says. It's they look at this. They look at your polynomial, and first they call the constant term, they call that p, and they call the leading coefficient, they call that q. I don't know why they reverse the order of the alphabet on it, but that's what they do. And there is a way of finding all possible rational zeros, all possible answers. And here's how we do that. It's not too hard. Sometimes it can be very tedious. But what I'm going to do is I'm going to put a P and I'm going to put a Q. Put that down just a little bit. So there's P and there's Q. And what I want for P is I want all the factors of P. So any number so if P is 6, what are all the numbers that go into 6? 1, 2, 3, and 6. Everybody okay with that? So all the possible factors of P are 1, 2, 3, and 6. And what are all the possible factors of Q? 1 and 2. Everybody with me so far? And now what our job is we are going to write down a bunch of fractions. And here's how we're going to write down our fraction. This is going to be your numerator. These are your possible numerators, and this is your possible denominators. So when I do P over Q, here's how it works. I'm going to do this over this, which is 1. I'm going to do this over this, which is 2. I'm going to do this over this, which is 3. And then I'll do this over this, which is 6. Right? But these are your numerators and these are your denominators, right? So I'm going to put basically all the combinations with the 1 as a denominator. Now I want to do all the combinations with 2 as a denominator. So 1 over 2 is going to give me 1/2. 2 over 2 is 1. Already have it, don't need it. 3 over 2. Then 6 over 2 is 3. Already have it.
A little bit to the left. Thank you.
Okay. So when I do 3 over 2, when you write these out, you have to sort of keep track of, if you've already got one, you can't write it down again. Like, you've already written down 3, but if you wrote down 6 over 2, that's the same thing as 3, and so we don't want to write that down again. And then lastly, you have to take care of the positive and negative. So technically, it's plus or minus, 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 plus or minus. And these are your possible answers. Right? These are our possible rational zeros. These are our possible answers.
So how did you get the 1 over 2 and the 3 over 2 again?
So,
Oh, you just divided the 2 going to 2, okay.
yeah. So I have to do all combinations with this as a denominator. Dun, 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 dun. Then all combinations with this as a denominator. Dun, 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 dun.
Okay.
And that's what I wrote.
Is the first one after QI?
No, it's a 1.
So 1.
Oh, okay.
So now I've got a kind of a silly question. So how many zeros am I supposed to have?
3.
And can we agree that this is a lot more than 3?
Yeah.
Just want to make sure we're on the same page, right? So these are my possible answers, which is way more than how many I'm going to have, right? So now we have our, now we have the sort of discussion is, okay, how do I factor this? Well, how we factor this is kind of what we have to do what we did last week, where we have to find something that works. And what I mean by find something that works is we need to find something that divides evenly into this. And how we do that is we're going to use synthetic division. And so synthetic division, what I want everybody to do is write these coefficients down. So we're going to write our coefficients down. There's a 2, there's a 1, there's a negative 13, and there's a 6.
Wait, so we don't want them.
All right. Everybody see how we got synthetic division and we're ready? All right. And our job is we've got to find something that works. And here's what I mean by something that works. You put something here, right? And it works if you get a 0 as a remainder. Because if you get a 0 as a remainder, that means it divides evenly. Right? I want to make sure everybody's at that spot. All right, so now we start guessing. What do you think my first guess is going to be?
I think this was on the quiz.
Yeah.
Okay.
Okay. So what can I guess? Actually, what on the quiz they told you what to guess. Here we're guessing. So if I just got to randomly guess, I mean, these are my guesses. I always guess 1. I start with 1. So if I start with 1, now I want to find out, my goal is, if I get a 0 here. All right.
Negative or is it just positive?
I just, well, if 1 doesn't work, then I'm going to try negative 1. Right?
You don't have to switch the signs with the
No, we're just checking to see if we're trying to find something that works. And so And so if I try 1, let's see if 1 works. I'm going to bring the 2 down. So 1 times 2 is 2. I'm going to add that, get a 3. 1 times 3 is 3. I get a negative 10. Is this going to work?
No.
Now, once you find out it's not going to work, don't keep going, right? Because we know our goal is I want a 0 here. If I don't get a 0 here, that means I need to change numbers. All right, 1 didn't work.
So you, and then I tried to get to a negative and it also didn't work. In the future, do you just give up on that number entirely?
Well, no, if 1 doesn't work, negative 1 could work.
Oh, okay.
Yeah, you have to, I always try plus, my first guesses are plus 1 and negative 1. And so you've already found out that negative 1 doesn't work.
Yeah.
Okay, so you go through, and okay, so you say negative 1 doesn't work, let's see. So I get negative 2, so it's negative 1, that gives me 1, I get a negative 12, no chance, right? Right, remember, we want to get a 0 here. Can everybody see we're not going to get a 0? All right, so we know 1 and negative 1 doesn't work. All right, what's next? I'm going to try 2, and maybe this works. So I bring the 2 down, 2 times 2 is 4, gives me a 5, gives me a 10, gives me a negative 3. Does 2 work?
Yes.
Okay? This is huge, right?
Oh, wait.
I want to make sure we understand the idea of this works, right? And so if 2 comes in, it works. I get a 0. And the significance of that is, if 2 works, what's going to be a factor? X minus 2. So this is going to factor as x minus 2. All right? Is everybody okay with this? So, like, our goal is, when I'm done with this whole thing, I'm going to have, like, something times something times something. Like, I'm going to have this times this times that. So I'm going to have 3 things when I'm done. And what we just found out is that 2 works. Curious, is 2 one of the numbers on my list?
Yeah.
Yeah. All right. There's a bunch of other numbers on the list, but 2's on the list. All right. Okay, so now, how do I find out what goes here? How do I find out what goes here?
You divide that by.
You take this divided by that. Well, didn't we already do that?
Oh, so it's right there.
Yeah.
Oh, so.
Does everybody see that? Right? This is a very important idea, right? If your goal is to take this and break it apart so it's, in this case, x minus 2 times something else, how do you do it? Well, you have to take this divided by x minus 2. Well, you've already done that. And since we've already done that, it's going to give me 2x squared plus 5x minus 3. There. Now we're not done because I want to factor everything. So to factor everything, can I factor this? Yeah, I hope so. Right? So that's going to give me, I'll have a 2x and an x. Let's see, the 3, maybe a plus 3 and a minus 1. Let's see, 6x minus 1x gives me 5x. And then I have an x minus 2. So now I've got my 3 factors. So if these are my 3 factors, I'm going to erase those. What are my zeros?
2, 1, and negative 3.
2,
Oh, wait. 1
1/2,
half.
and negative 3. And I wish I hadn't erased the bottom, but those 3 numbers were part of that giant list, weren't they? Okay. Did everybody see what to do? Or at least in this example, did you see what we did? We started with a polynomial, right? And our goal is, to get basically these last 2 things. Get my factors, get my zeros. And, well, we've got to figure out what goes into it, so we start guessing. How do we guess? Well, the rational root theorem gives us this list of numbers, and so we start trying those numbers. Now, did the rational root theorem really help us? Not really. We wrote a bunch of numbers out, right? And we basically, that may have helped guess a little bit. In practice, it really doesn't help us guess out at all. You always guess plus or minus 1 or plus or minus 2. And usually one of those works. But let's try it again. Right, so I wanted to do, let's start off with x cubed minus 6x squared minus 13x plus 42. And while it doesn't help, I still want to make sure we practice. I want to write down my rational roots, my possible rational roots. And so my possible rational roots, here's my p, here's my q. And so when I write these down, I have p and I have q. So what are my factors of p? A lot. 1, what else? 2, 3, 4 doesn't go into it, 5 doesn't go into it, up 6, 7, well 8 doesn't go into it, 9, 10, 14, then 21.
And it's what goes into 42?
Mm-hmm. Because you're looking for all your factors. These are all factors of 42. And, well, I need plus and minus all those.
42, right?
Yep. Oh, and 42. Oh, incidentally, one question on your test in Alex is going to be list all possible rational roots. And if I say list all possible rational roots, I'm not asking you to find them. I'm asking for this list. And in Alex, they actually have a special, you know how sometimes they have a little special thing for a fraction or a special thing for an exponent? They actually have a special thing for plus or minus. So you have to click the plus or minus for every one of these.
What if you listed, I guess you wouldn't do this, but what if you just did plus and minus each one? Would that be points off?
No, I think it'd probably take that. Alex has smart, I mean, here, I'll pause just for a second. Oh no, I didn't mess up. This was P. I messed up by putting the plus or minus. Because what are your factors of Q? 1. So if I wanted to do P over Q, that's going to be 1 over 1, 2 over 1, 3 over 1, 6 over 1, 7 over 1. And so my factors of P over Q, that's going to give me the plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 7, plus or minus 14, plus or minus 21, and plus or minus 42. I messed up when I put the plus or minus in here, because that, we won't worry about putting a plus or minus on the P over Q. So these are my guesses. But how many answers are we going to have? How many zeros are we going to have? 3, right? That's well more than 3, isn't it? All right, so let's try to find stuff that works. So the way we try to find stuff that works is we use this embedded division thing. So I'll put 1, -6, -13, and 42. So I want you to try. All right, we're gonna try things. Does 1 work? No. I mean, you can try it, right? But you find out quick. The idea is once you find out it doesn't work, stop. I'm going to try 1. Okay, 1, -5, -5. No way that's going to work, right? There's no way I'm going to get 0 at the end of this. Does -1 work? No. Does 2 work? Does 2 work? So let's see. Yeah, I'll bring the 1 down. That's 2. I get -4, -8, -21, -42. Does 2 work?
Yeah.
So if 2 works, what goes here. I get an x minus 2, and then what goes here? X squared minus 4x minus 21. Now I get a quadratic, right? Can I factor that? Hopefully, all right? And so when I factor that, that's going to give me an x minus 7 and an x plus 3. I still have my x minus 2. So now that I have my factors, what are my zeros?
2, 7, negative 3.
2, 7, negative 3. Does that make sense? All right. One more. Right? So I want to write down my possible rational roots. Right? I have a feeling I might get some groans in just a little bit. But, so here's my P, here's my Q. So what are my factors of P? What goes into 30?
1, 2, 3, 5,
6, 10, 15, and 30. All right. What are my factors of Q? 1, 2, 3, 4, 6, and 12. All right. Everybody okay with this? And so now, don't worry, I'm only going to make you do this once because this is a bit excessive. If I want to find my possible rational roots, I got to think of all possible combinations of these as my numerators, this is my denominator.
Oh my god.
Good, you understand exactly how long that's going to be, right? Can everybody kind of envision that when I finish writing this, I'll be somewhere over here. I'll just open the door and keep walking out. Right. It won't be that long. It's not short, okay? But it may not be as long as you think because remember, we can't write down answers more than once. If you write down answers more than once on Alex, it'll mark it wrong. And I want to make sure we learn how to know, we learn to look for, first, what's a pattern? Because you got to develop a pattern to write all of these out. And so here we go. So if I want P over Q, I want all combinations as 1 as the denominator. Are we okay? That's 1 over 1, 2 over 1, 3 over 1, 5 over 1, 6 over 1, 10 over 1, 15 over 1, 30 over 1. So I'm going to write that down. So that's going to give us 1, 2, 3, 5, 6, 10, 15, and 30. Everybody okay with all combinations with denominator 1? All right. Now let's look at denominator 2. 1 over 2. So far, so good? 2 over 2. That's 1. Already have it. Don't need it. Everybody see that? Okay. 3 over 2. Oh, that's new. 5 over 2. Well, that's new. 6 over 2 is 3. Already have it. So I don't write the 6 over 3. Okay. 10 over 2. That's 5. We already have it. 15 over 2 I don't have. 30 over 2 is 15. Already have it. All right, so now we finish with denominator 2. And so now let's look Let's look at denominator 3. Well, 1/3 I don't have. Here, I'll start writing down here. 2/3 I don't have. 3/3 I have is 1, I already have it. 5/3 I don't have. 6/3 is 2, already have it, don't need it. 10/3. 15/3 is 5, already have it, don't need it. And 30/3 is 10, already have it, don't need it. If you follow this pattern, anytime the fraction reduces, you already have it. All right? Okay, so now I've finished with denominator 3, so now I go to denominator 4. Well, I don't have 1/4. 2/4 reduces to 1/2, already have it. I don't have 3/4. I don't have 5/4. 6/4 reduces to 3/2, already have it. 10/4 reduces to 5/2, already have it. I don't have 15/4. 30/4 is 15/2, already have it. When I go to 6, I get 1/6. 2/6 is 1/3, already have it. 3/6 is 1/2, already have it. I need the 5/6. 6/6 is 1, already have it. 10/6 is 5/3, already have it. 15/6 is 5/2, already have it. 30/6 is 5, already have it, don't need it. When I go to 12, I need the 1/12. 2/12, already have it. 3/12, already have it. 5/12, I need. 6/12, already have it. 10/12 I have, 13/12, and 30/12 reduces to something I already have. And I'll have to use that special thing of a plus or minus next to everything on plus or minus, plus or minus, plus or minus, plus or minus, plus or minus.
What about 15/12?
That reduces,
Oh, yeah.
because 15/12 is going to be 5/6.
Yeah.
No, 5/4.
Is there gonna be a question like this on the test?
Not this long. I'll go ahead and tell you, there is a question where they give you a polynomial and they say list possible rational zeros. And you've got to write them all out. You don't have to solve, you have to list. And it's not nearly this long. This is excessive. But I wanted, yes?
Are textbook questions like this, since they're usually pretty popular?
Well, I'm not assigning stuff out of your textbook as I didn't like it. Actually, no, they aren't actually this ugly. There might be one, I can't remember, but I didn't like the problems out of the textbook. All right, so does this really help us narrow our guesses? No, I mean, we write down virtually every number, right? So we're still kind of guessing, aren't we? So, but I mean, my goal is I still want to find the zeros and I want to find the factors and zeros. So to find the factors and zeros, let's see, this is going to give us 12, 59, -11, and -30. And so now we start our guessing game. I'll help you out a little bit. 1 and 2 don't work. Plus or minus 1 and plus or minus 2 don't work. Right? When I made this problem, I purposely made it where 1 and 2 didn't work. Right? You could try 3. It's not going to work either. Right? You can try lots of things. They won't work, right? But I also wanted to revisit, you know, most of these answers, possible answers, are fractions, aren't they? I'm actually going to try a fraction. Right? And I want to make sure we know how to try fractions, and I also want to make sure that you understand when fractions work and when fractions don't work. Right? So, well, 1/2 is a fraction on our list. I'm going to try 1/2. Don't try it, just watch. Right? I'm going to try 1/2. And when I go through 1/2, okay, well, I bring down to 12. 1/2 of 12 is 6. That's going to give me 65. 1/2 of 65. At this point, I know it doesn't work. And here's why. Remember when we started doing this, when I made you do a fraction, I said you'd never you'd never get a fraction here? If you ever get a fraction in this line, it doesn't work. Do you see that we're going to get a fraction here? So at this point I can stop. I know that 1/2 is not going to work. So what does work? Well, I'm going to try, what does it look like when it does work? So I'm going to try -2/3. Right? I mean, that's kind of a far stretch, right? You try a bunch of other numbers before you try that, but okay. We're gonna work through -2/3, and I want you to see how it works. All right, so you bring the 12 down, and now you got to multiply -2/3 times 12. Now here's what you do. It's not hard, all right? What you do is you're going to multiply -2/3 times 12, so you think, well, this is -2/3. I'm going to multiply it times 12. This is what I do in my head. How many times does 3 go into 12?
4.
What's 4 times -2? Now I add, I get 51. And now I want to do -2/3 times 51.
How do you get 51?
59 minus 8.
Oh, I thought that was a 54.
My handwriting's bad. What's that 9 was there? Okay. And so this, 3 goes into 51, 17 times. What's -2 times 17?
-34.
Yeah. We get our -34. And so when I add, that gives me -45. Good, right? Did it work?
Yes.
It worked. Also, did we get a fraction anywhere along this way? Right. So when you're trying fractions out, sometimes using fractions isn't as painful as you might think. All right, so now let's go back up here. How do we factor this? Well, what goes here? If -2/3 works, what goes here?
3x plus 2.
Unfortunately, no. X plus 2/3. When you use synthetic division, whatever this number is, you have to use. Our final answer is going to have 3x plus 2. When everything's said and done, we will have a 3x plus 2. But right now, you have to use the 2/3. Okay, and you're going to find out why in just a minute. And what goes here?
12x
Yeah.
squared plus 51x.
12x squared plus 51x minus 45. All right, does everybody see how? Because this is kind of consistent with the previous two examples. Right? It's almost identical, but we have to do something. Is there something in common here?
3.
A 3. And so what I'm going to do is I'm going to factor the 3 out. And if I pull a 3 out of this, then I'm left with 4x squared plus 17x minus 15. Then I have the x plus 2/3. The space. And here's the trick. That 3 that we pulled from here, we're going to take that 3 and distribute it to this. And what happens if you distribute the 3 to this?
3x plus 2.
That's where our 3x plus 2 comes in. And so then we end up with a 3x plus 2, and end up with 4x squared plus 17x minus 15. Am I done?
No.
No. So I've got a quadratic, I need to factor. I think it's going to be 4x and x. And to get 15, that's 3 and 5. So make a plus. plus 5 and a minus 3. See if I got the 17. Minus 3x plus 20, that gives me 17x. So I have 3x plus 2. Now that it's factored, what are my zeros?
Negative 2/3.
Negative 2/3. 3/4. And negative 5. And all of those were in that massive list that we had. All right. So